Good morning, guys. So here is this morning's person. This was 45,000 epochs, and as you guys noticed, the background is now sharper. I mean, certainly I am not very sharp here, but when you think that this is only 1900 steps, 1900 images turned into this manifold, that's pretty cool. Let's see. So it's kind of like you saw there. I guess that momentarily it resonated with my image very well, but I mean this is that system where you could take say a podcaster and kind of make a mirror of them. It's well probably a bad thing, but anyway, so it's not your average deepfake system. I was asking why is it not sharp, and of course it's only 128 images, and the reason why I kind of like have stayed here is because my computer training, it gets pretty well. It's already doing that is pretty hard. And about the training, so it was training overnight, so this got to 45,000 steps. The earlier systems would have gotten there in few hours, but this has some super complicated mumbo jumbo built into it that we came up with yesterday, which is, for example, that whenever there's an image, there's bits of it that are stiff and bits of it that are not stiff, which means that when I'm driving with the thing, I'm not driving the whole field. I'm mainly driving just the avatar here, and that leads to the more kind of a natural image, so we don't get the fibery bundles here and Moira effects too much. And that's actually, well, this is the thing that was supposed to do it, but I guess we have it even without it. But clearly, that whatever complex maths that went into it yesterday um, made the thing stabler because we had a or more stable, let's say. Uh, we had the earlier thing. We had actually one that was trained 76,500 epochs on the old thing, the legacy version, and you always have to do this. And basically, we would get the fiber bundles, but this thing actually somehow gets rid of them mostly, but you see them on the faces. Now, how could we have this thing even sharper, like we're talking here with Gemini? This is the new 3.6 Flash, at least this, yes. So this is best Flash version right now. So we had only certain amount of high frequency splats here. So all of this you could, okay, here. So we have 100 packets are allocated to Octave 5, the finest texture band. So we kind of have the same thing as with the brain, that there's the low, the rough, the V1, and then we go to IT, and they have different amount of bandwidth. And here, because the bandwidth for the high texture is low, we don't get the high texture on the faces, and of course also because it was just a random 1900 image, me moving a little bit, just opening my mouth and so forth. So this thing, once again, just trained on this. We don't get high texture and so forth, but all of that could be perhaps fixed here in the thing. Like if we look at these settings here, you could go here and perhaps change the image setting and so forth. And what it was saying, this is, I think, is in a code that with band mode is per mute. Wavelets aren't enough to cover both the moving face features and background edges simultaneously without blurring, so that could be one thing. Then I had a weird idea this morning because that's what I do. I had an idea like, what if we had multiple manifolds? So what if we had a, let's say that we had a discussion with the person, and when I'm moving, the other person is moving, and we are actually training on the movements of the other person as a reaction to my thing. You guys get where we would get there. So you would learn kind of like you're talking with someone and the other someone, you get their response from my movements. Now that would be weird as anything. But then if you follow that logic and you go chaining manifolds, secondary movements, and there could be more of them, like it could be yet another thing, then things start to get really, really weird. Chaining continuous learned manifolds evokes three compelling paradigms. So here you can see kind of the idea. A sympathetic resonance and coupled oscillators in physics. If you place two pendulums on a shared wooden beam, and okay, so that's that kind of like have a feeling it kind of didn't get it. Coupon operator cascades. You create end-to-end differentiable physics pipeline. But so okay, so I could just do this to these changes to make it sharper. But as I said on the repo, this is a work in progress. What could this be good for? One mind-blowing thing is that this makes it possible, especially if you get it sharp, like kind of not really great, of course. But let's say that we had like Casey Neistat or whatever you could make, especially with faster computers. Very fast is kind of a blurry version of somebody, and you could drive it very easy, and it's not hallucinating and all that. So deepfake, I guess, with just some images, which is. I remember I was thinking of that like 2-3 years ago, and you do it with the normal AI methods. Well, you can do it with the normal AI methods, and there's normal AI, deepfake, and whatever. But one thing is that you would get the kind of natural movements they have, because if you have the movement actually comes from my movements on the frozen images. But I guess still playing with this a little bit, and it gets mad. Anyway, I hope you guys saw that. Bye.